substitute this value of y dash and y double dash in the differential equation. X y dash plus x square minus 1 by 9y is equal to 0. And then um, we need to obtain the initial equation. So initial equation, when this coefficient of x to the power r will be equal to 0. So for that, what we will do, we will take the um, like we will take the common value m plus r minus 1. Then what we'll get, the common value is amx m plus because here is amx, so m plus r will be the next, then 1 by n amx m plus r, and this will be in outside. So the problem was, we need to shift this value m to m minus 2. Why? Because we need to change the coefficient of x to xm plus r. So only it is possible if m become m minus 2. 2 will get cancelled. So this happens, and then the limit will change from 0 to infinity, it will change to 2 to infinity, and then I can directly write this equal to 0. If we put m is equal to, because for first value we can put m is equal to 0, then r is equal to plus minus 1 by root 3. This is the root. Now let's see again one more example. We need to find out two Frobenius solution around x is equal to 0 of this differential equation. You can write this differential equation like this. Divide this throughout by x squared. And x is equal to 0 is regular singularities. Why? Well, x is equal to 0 is a singularity, but if we can define a qx, and then if we multiply that with x square and then take limit x tends to 0, then we will get a finite value, so it will call as regular singularity. We can assume solution of this form x am Frobenius. We need to we directly cannot use the power series method, which will be inapplicable, will not be applicable for this kind of singularities. We need to do use of the Frobenius method. So this is the Frobenius expansion. If we do the double differentiation and I will put the value, then we will get equation like this. If we take common, am x m plus r and x m plus r plus 2 will be outside. We will change m to m minus 2. Why? Because m minus 2 will 2 get cancelled. And if we do that, we'll get this equation. And if we put m is equal to 0, why? Coefficient of n is equal to 0 must vanish. So we will get this root. One is 5 plus 6, one is 1 by 6. One is 5 by 6, 1 by 6. Next, when the root is 5 by 6, then we can find out the value of am. Well, how do you find the value of am? If am will be like this, am will be equal to am minus 2 divided by m plus r and plus or minus 1 plus 5 by 36. Then we can see the relationship between m and left side, left hand side and right hand side this equation is only even. Why? Because am only depend on the even term m minus 2. There is no odd term, so this is why this equation will only hold true for even term. Odd term will be evaluated to be 0. A1, A3, A5, A7 will all be 0. So if we put m is equal to twice k, then what we will get is minus a twice k minus 2. Then we will get m is equal to twice k, then 5 by 6, twice k minus 1 by 6, then 5 by 36. If we evaluate it, then we will get this equation like this. And for k is equal to 1, we can find a2 is equal to, in terms of a naught, we can find the solution. So this is the solution of the Fourier solution, one solution. According to, if we use the root of r is equal to 5 by 6 in this equation, then we will get this value. Then, okay, so this is the first solution of this using the Frobenius method. But here we can see, the Frobenius equation was like that. That our solution would be in the form of summation m0 to infinity am x to the power n plus r, right? And then we differentiate it and then we find the coefficient value. Why we need to find the coefficient value? Because uh, we need to find the coefficient value to write it in terms of the expansion. And what we get the odd coefficient will be odd coefficient will all get evaluated to be 0. Only left will be the even coefficient. So the equation will be like x to the power x to the power r, right? X to the power r, then x to the power uh, m. The coefficient was am, but we can say that the coefficient am will be, all of this will be even. So a twice k, value of this will be a twice k. Then x to the power r was there, but what about x to the power n? Well, x to the power n will be, like x to the power 0, then x to the power x squared, then x cubed. So this will be like n. N value will get summed. Then question is, what about the second solution of this differential equation using the Frobenius expansion? So for finding out the second solution, we will use again the you know coefficient formula, and we will put the value. The root is 1 by 6, and we will get for even odd term will be again 0. For even term we will get expansion like this. So since r1 minus r2 is 2 by 3, not an integer, so two solutions are independent. Remember that. Two solutions will be independent. Why? Because uh, if their difference is an integer, then two solutions will be dependent. And the first question was, why coefficient of the lowest power is equal to 0 in indicial equation? Why we do that? Well, we assume the solution of the form y is equal to summation n 0 to infinity n x to the power n plus r, right? And where a naught is 0, first coefficient is not 0. After putting y double dash into the differential equation, we get like we will get this coefficient and x to the power n plus r something equal to 0. Now the lowest power of lowest power of x when n is equal to 0. If n is equal to 0, what was the lowest power? Well, lowest power is uh, x, like x to the power r, right? Because n is already 0, x to the power r, and x to the power n plus r become x to the power r. So for this equation to hold for all x, so every coefficient of x to the power n plus r is equal to 0 independently, since x terms are linearly independent. Now coefficient of this is equal to 0 for all n. Now n is not equal to 0 by definition. The only way equation hold if bracketed term will be equal to 0. Why? So that this is why we equate coefficient equate to 0. Now, why odd coefficient are 0? Because there is no dependency, right? With the odd term. These are some important thing you need to remember, that if f of x is summation 0 to infinity a n x to the power, and then f dash will be n a n x to the power minus 1, then uh, but we can write uh, also in terms of a n x minus x naught to the power n, and then we can differentiate it. But if we integrate it, then it will be an, because integrated according to the variable x, right? So an x minus x naught n plus 1 divided by n plus 1. That's, and cos n pi is equal to minus 1 to the power n. So we're going to learn about the Fourier series. Now, how do you solve this kind of equation? Like if in the left hand side we get a coefficient bn and sine n pi x by l, and we are going to equate with a finite value. Then what about the bn? How do we find bn? If we could write this RHS also an expansion of sine function, then it could be helpful, right? Because we will then equate this expansion this to the right hand side expansion. So how to do that? Well, we're gonna learn about this. Now, a function which has a period t and which has a finite number of finite discontinuous in one period. Well, first of all, which has a finite number of finite discontinuous. If discontinuity this finite number of finite discontinuity is not infinite. That means the limit will not tend to infinite. Well, so a function which has a period t and which has a finite number of finite discontinuities is one in one period is, let's say a function have period 0 to t, right? 0 t by 2, uh, then t by t by 2t by uh, so let me show it, uh, like if this is a function, this is 0 and this will be t. A function is like this. So what happened? This is t by 2. This is half. Next, what it will be? It will be t by 4, right? T by 4, and this should be 3t by 4, because we are dividing 0 to t in 4 parts. Now, in this one period, if the function has finite number of discontinuities and uh, finite discontinuities and finite number of finite discontinuities, what it means is, so if the function even does not, if left hand side, if there is a function, if there is a left hand side is like this, and right hand side the function like this. So here we will get a point where left hand side, right hand side does not equate, but they both exist. So this is called discontinuity. But here you can see the discontinuity is not infinite. For some function like 1 by x, at x is equal to 0, discontinuity will be infinite. You can see it in from graph where if x is equal to 0, this will be infinite. If x is equal to 1, then value will be 1. If x is equal to 2, then value will be 0.5. Where is the 0.5? Why value is 0.5? And x is equal to, so graph will be like this. But when x is equal to 0, it will go to infinity. It will not touch. It will not touch this. So this is infinite discontinuity, infinite discontinuity, but this is finite discontinuity. This is finite discontinuity. But this is infinite discontinuity. we are talking about the finite discontinuity here. So if if a function has a period t and which has a finite number of finite discontinuity in one period, this can be explained in or it can be written in terms of an infinite series. A naught that function can be written as a naught plus summation n is equal to 1 to infinity, then an cos 2 pi nx by l and bn plus bn sine 2 pi nx by l. Now, what about this f of x? Yes, this will be our f of x. So t of x can be written because if t of x, if we take t of x as 100 by lx, this function we will take this as like 100 by rs, and if it is a periodic function, and if it has period, finite period and finite number of discontinuities of finite discontinuities, then we can write this as this function, and then we can evaluate its coefficient like like this, because a naught will be what a naught is 1 by 2 l, while 2 minus l f of x dx. Simple. And will be like this, and bn will be like that. And then if we put the value, a naught will be 1 by 2 l, l2 minus l. So t of x 0 is 100x by l. So this is nothing but x squared by 2, and 100 by l will be in outside. So l into l square, 2 will be also outside, and x square l2 minus l will be equal to 0. And an we can write this value. This will also equal to 0. Only bn will be a finite value. So Fourier series of this tx0 will be nothing but this summation and 1 to infinity 200 by n pi and sine n pi x, because where sine come from, so this b naught value, the bn value, sine. This integration we have done, and sine. And after that, we can expand it, right? We can expand it for sine 1, 2, 3 like this. Here are some of these nodes, the table of method of undetermined coefficient, where if the form of this forcing function is like a e to the power kx, then we have the nature of this auxiliary root. K can be uh, k might not be a root, and k might be a single root, and k is double root. If k is not a root, then the form of particular integral will be c e to the power kx. K is a single root, then c x e to the power kx. If k is a double root, then c x square e to the power kx. If it is polynomial function forcing equation, then ax to the power n. Then if k can be 0, so k is not a root. K can be 0, and it is a single root. K can be 0, it is a double root. If it is not a root, then it's the equation will be c naught plus c1x plus c2x squared. And then if it is single root, then x c naught plus c naught 1x. If it is double root, x squared c naught plus c naught 1x. So you can check this for also a cos kx or a sin kx. Now, second order linear partial differential equation uh, can be written uh, like this. And if this coefficient value a c minus b square is greater than 0, this equation will be elliptic. And this equation, differential equation, will be elliptic. If ac minus b square is less than 0, it will be hyperbolic, and if it is equal to 0, it will be parabolic. Now, Fourier series for a function fx defined on the integral, this can be written as like this. We already saw that. And here are some of these important note. If f of minus x equal to f of x, that it will be called as even function. If it is f of minus x is equal to minus f of x, it will be called as odd function. If f of x and g of x are even or odd function, then f of x plus gx is an even odd function. Like if we add this, then we will get only the even function. We take the difference, then we will get even or odd function. But two most important thing we need to remember is Fourier sine and cosine series. Fourier series for an even function on an interval is a cosine series. Remember that. So f of x will be like this: a naught plus summation 1 to infinity a n cos n pi x by l. If f is even, the bn term will be equal to 0 because bn have sine term and sine value are 0 for an even function. And coefficient will be only for a naught and an. And for the if the function is even, function is odd, then only sine term will remain, the cos term will get 0, and also the constant function will also be equal to 0. So only left term will be summation and 1 to infinity bn sine n pi x by l. We are going to extend the scope of this Fourier series. So let t of x is equal to 0 will be a function. Then if it is an arbitrary function, now if we could expand f of x in terms of sine, it would be like this only. Now we know that there would be a Fourier series of this type only if fx was on the interval minus l to l, which is different from 0 to l, right? Because the f of x is in 0 to l, but this is possible only for minus l to l. This should be available. Now, in order to do this, we extend the definition of the function to the whole x-axis in such a way that the extended function is defined over minus L to L. Then we can even find the Fourier series for the extended function, but use it only over the range for which the function is defined. Let's see, half range expansion. Now, we like to extend the function f(x) on interval 0 to L so that we can represent it as a Fourier sine series. For this, we define now odd function minus L to L. Now g of x we define, and then we define that for minus L to 0, function is minus f of x, and x is equal to 0 for 0, and for 0 to L it will be f of x. For 0 to L we get the function f of x, but if we extend this for 0 to minus L, we will get minus f of x, right? So this is what we do get this after extension from minus L to L. Now here gx is defined in the way is called the odd extension. Gx is called the odd extension of f of x. So function is 0 to L, right? And function is defined on f of x as 0 to L. But what we need is a function which should also defined in 0 to minus L. That is why we do this odd extension. And then g of x will be odd extension minus L to L. The cosine coefficient will be equal to 0 only, but Bn will be the sine coefficient, but gx is f of x in for 0 to L, and then we get the value. Now suppose we need to develop a cosine series for the function on interval f of x on interval 0 to L. So we define what? G of x function is defined on 0 to L. We need to define f of minus x minus L to 0. Why we are doing this even extension? Like what we are saying is g of x will be equal to just f of minus x. Why we do this? Because f of minus x, we are trying to say that uh, even if we put x value of the x as minus x in the number line 0 to minus L, we get the positive value. We will get the positive value. That is why where this is called the even extension. This was the odd extension. So in odd extension, we say that it will become gx will become minus of f of x, right? So y become minus of f of x if we put the value 0 to minus L. And here we are trying to say that it will become plus of f of x. But if even if we put x value in number line 0 to minus L, that is called the even extension. So the coefficient odd term will be 0, so only left will be the a0 and an term. Next is f of x is the function will be like this: 1 from 0 to half and 0 from half to 1. Let's do this odd extension. Odd extension means we need to define a function 1 to 0. It is only defined for 1 to 0. When we define the function that it will become negative from minus half to minus 1, it will become 0. This was easy. But for 0 to minus half, the function should be minus 1, and for 0 it should be 0. This will be the odd extension for this function. If we do the odd extension, we will only get the value of the sine function bn, the coefficient of bn. And if we put the value of the bn, we will get we will just substitute the value of f of x, which is nothing but 1 sine of n pi x dx. We'll get the answer. Then yeah, so 2 by sine, integration of sine n pi x will be cos n pi x. The answer we will get. Then next 5 is from equation 5 is formed from f of x. Yes, so they are asking about how we will get this expansion. Well, we will get the expansion from finding out the coefficient. The final solution should be in the form of from n to infinity, summation term from n1 to infinity. Then writing in terms of the coefficient, we are going to multiply it with bn, and then we're going to multiply it with sine n pi x by l. Now, sine n pi x by l was already there, but we just already found the we just found the coefficient bn value. Then we're going to multiply the bn value with the sine n by x by l, and we will get the expansion. The next thing is for the second second dimensional differential equation, we have to represent arbitrary function as Fourier series in terms of variable. Yeah, we can do that also. Now, Fourier series of double variable function. The question was whatever we did earlier was Fourier expansion in for the single variable function. Now, what about the double variable function? Now, suppose f of x y is a double periodic with the period twice L in x and 2h in y, 2L in x, 2h in y, means like the function will be like x plus 2L, y is equal to f of xy, and x y plus 2h is equal to f of xy. What happened then? Well, it is also similar. You're going to write this f of xy as summation n 0 to infinity m 0 to infinity. Then the coefficient will be a and m cos n pi x by l cos m pi y by h, then plus this will be our the first coefficient a and m, then second b and m cos n pi x by l sin m pi y by h, and plus c and m sin n pi x by l and cos m pi y by h, plus d and m sin n pi x by l sin m pi y by h. Then we can just find the a and m value 1 by lh, h2 minus h, l2 minus lf of xy cos n pi x by l cos m pi y by h and dx dy. So the b value would be cos and sine value, and c value would be sine and cos value, and d value would be just sine and sine value. Similarly, for third dimension, if we put x, y, and z, then we will get n 0 to infinity, m 0 to infinity, and p 0 to infinity, a and mp cos n pi x by l cos m pi, because you can see here the function what was we got earlier. It was the function said that function can be written as an a naught plus an cos twice cos n pi x by l plus bn sin n pi x by l, right? So what they are doing is, so they are saying yes, that is also true, cos n pi x by l cos m pi y by h. Why? Because this will be for second variable, and for third variable cos p pi z by k. Then all the 8 combination will be there, and the coefficient n pi nmp will be like lhk 1 by lhk, and you will get summation. All of value would be for cos, then next value would be cos sine sine, then next value would be cos cos sine, then next value would be sine sine cos, the next value will be sine cos cos. It will be like that. Next we're going to learn about the legendary polynomial.